to explain my project fine-tuning large language model for medical diagnosis. A fine-tuned large language model tailored for the medical domain can be created to achieve the objective of improving diagnostic procedures, reducing errors, and ensuring patients receive the most accurate and timely care possible. For this project, a large public dataset, ai-medical-chatbot, was collected from Hugging Face, and this medical QA dataset with each sample containing instructions, patient input, and doctor output was used for supervised fine-tuning of LLM. And the introduction part, this code is done using Google Colab. And then introduction part, for the fine-tuning task, I have selected an AI chatbot from Hugging Face, and we'll be working with the Google Flan T5 model, renowned for its high-quality instruction-based tuning. To enhance the model's performance, we will engage in parameter-efficient fine-tuning, especially LoRa method. And the first step is installing the essential setup and libraries. So importing the necessary libraries and setups, the environment for the notebook, such as importing torch, dataset, transformers, and other required libraries. This code is for checking the GPU. So installing torch, datasets, transformers, and other libraries. So evaluating the log score. So we can use the dataset directly by copying the dataset path, and we can download through Colab. We can directly download from Hugging Face this dataset. This is the dataset name, and load the dataset using dataset library. It defines the dataset object that will be used for throughout the notebook, and displays the first few rows for samples from the dataset to give an overview of what data look like, and prints the column name of features present in the dataset. And this line of code is splitting the dataset into training and testing sets. So I only use 100 samples for quick demo because the dataset is too large and it's huge. So I have only chosen 100 samples for this task. So here 10% is the dataset is split for 10% as test and 90% as train, because it's a huge data, so I have split it like that. So dataset displays the structure after splitting. You can see as 900 train and 100 test, and retrieves and displays the first sample from the training set, and also retrieves and displays the first sample from the testing set. So dataset has been divided into 3 parts: train, test, and validation. So this cell randomly select and print a dialog and summary pair from both the training and testing sets. This is used to inspect the data. Next is model preparation and fine-tuning. So here the data is pre-processed into prompt response pairs. Specifies the model name Flan T5 and sets up necessary configuration, such as data type torch.bfloat16. Here I am loading the pre-trained LLM Flan T5 from Google and testing model without fine-tuning. And this is the evaluation step. These lines of code are used to load evaluation matrices Rogue and Blave using the evaluate library. Also, this graph shows the original model Rogue scores. And next is parameter efficient fine-tuning, which is used in NLP to improve the performance of pre-trained large language models on specific downstream tasks while using significantly fewer trainable parameters than traditional fine-tuning. And here we are seeing low rank adaptation, LoRa technique. So LoRa requires a few training or a small number of parameters only. Next step is the code initializes a transform-based sequence model for specified training with reduced precision. It is 4-bit quantization using float 16 and gradient checkpoint potentially tailored for efficient and specialized training. The code configures a LoRa setup for the model with specified parameters, then creates a LoRa adapted version of the model using the get_peft model function, and finally prints the number of percentage of trainable parameters in the adapted model. And the next codes are setting up a training process for LoRa adapted model with specific training parameters, trains the model, saves the model and tokenizer, then loads the model for generating responses to test the data, and finally comprises and displays the model's responses alongside baseline responses in a data frame. And it's plotting the fine-tuned model results. So these codes compute the ROC matrices for evaluating the performance of the fine-tuned model by comparing its generated responses to baseline responses. It uses a ROC metric from the ROC metric library, which assesses the quality of the generated text based on overlap with reference text. The results are aggregated and stemmed to provide a better summary of the model's performance. So here actually it's the fine-tuned model, but I have written it like original model. It's a mistake, sorry. Actually it is a fine-tuned model result. And this is a comparison between the fine-tuned and original model. Thank you.